Ms. Hubbard, and I'm here to show you guys how to solve for horizontally launched projectiles. So in the previous lesson, you were able to look at the horizontal and vertical components conceptually without numbers, and now we're going to apply that information to a word problem. So first things first, before we start projectile motion, I need you to make sure you have this table written before you start every problem. If you do not have this table, pause this video and look at the first thing that's listed for today's lesson, and you will see this table. Get into the habit of writing this table for every problem that you have with projectile motion because it will tell you which ones you will have to solve for as indicated by the underlines. And then you also have some information that's always the same. Okay, so here's our practice problem. A physics student throws a ball horizontally from the top of a building with a speed of 8 meters per second. The student measures the height of the building to be 15 meters. We are looking for the acceleration in the x direction, which is horizontal, and we're looking for acceleration in the y direction, which is vertical. Then we're going to look for the initial vertical velocity. What is the speed of the object that's falling in just the vertical sense or free fall? How long does it take to hit the ground? And how far away did the ball land? So as before, we're going to just work backwards and see what information that we need to solve. So let's look at the questions. First question asks, what is the acceleration in the x position or the horizontal position? Well, if we take a look at our table that you have copied, we see acceleration in the horizontal is 0 meters per second squared. So that's already written that in your table. We can move forward. Next is asking, what is the acceleration in the vertical? Well, when we're thinking of an object falling in just the vertical, that's free fall, and that's using the acceleration due to gravity. That number is always 9.8. But for our calculation, we're going to round it and we're going to use 10. Now, as you look at the table, you see that acceleration is a negative 10 or negative 9.8. Why? Well, the object is falling down. In the vertical component of the projectile, the object is going down. So therefore, we indicate that direction with the negative. Okay? So we have this part completed. Next question says we want the initial vertical velocity. So let's look at the vertical. Initial velocity is VI, and that number is always 0. Why is it always 0? Well, before we drop an object and it falls straight down, the initial speed is 0 because the object is not moving. So we will always have 0 as the vertical VI, or the vertical initial velocity. Well, those two were easy. The first two questions were easy because that's the information that we will always have. Horizontal acceleration is 0. Vertical acceleration is always negative 10. And the vertical initial velocity is always 0. Next question asks, how long does it take for the object to hit the ground? Well, anytime you're asking how long does it take, we're talking about time. So here at the bottom of my table, we see time is underneath the dividing line. That just means whatever number we have for time, we can use it in both the horizontal and vertical calculations. Why? Because even though horizontal and the vertical components are independent, they do not depend on each other. It still takes the same time for the object to fall. And since we are looking for it, we're going to put a question mark there where T is. Last question asks, how far away did the ball land? Where this is the building, we want to know how far did it land? Well, if you saw my hand, the direction that I'm going is horizontal. So that means we're looking for the horizontal distance. So that also has a question mark. Now let's go to our problem and get the information that they give us. We have a student who throws a ball with a speed of 8 meters per second. So we're starting off throwing that object at the speed of 8 meters per second. Well, that speed is going to go here under horizontal. We're horizontally launching it. Means the object is going to come out horizontally before gravity takes over and forces the object down. So on the horizontal initial velocity, I'm going to put 8. The student measures the height of the building to be 15 meters. We'll look at the word height. High. How high? If you look at the direction of my hand, we're looking at the vertical distance. High, height, and I also have the word in the table for you so you can always find it. We know our height to be 15 meters. Okay? And in this case, we don't have to worry about anything with final velocity. So do not even worry about that as far as calculating it. The problem didn't ask for it, and they didn't give us the information. Okay? So now let's take a look at the variables that we have. We have a VI, we have an A, we have B, and we have T. Well, we know that equation from our big four equation, and we're going to use equation number 2, which is V is equal to VI times time plus 1/2 the acceleration times your time to the second power. Okay? So let's look at what we need to solve for. Let's look at the horizontal because we have less information. We have a VI number, which is 8. We also have an acceleration of 0 that we can put here. And you know, anything times 0 is 0. So that means this part of the formula does not exist. Okay? We have to solve for a distance. Okay, so we leave that as D. Now, what about T? Well, T is also a question mark. So when we have our formulas, we can't solve for two unknowns at the same time. We need a distance number in the horizontal, and we need a time number, and we only have the VI of 8. Remember, I'm just looking at the horizontal side. We keep them separated. So I cannot solve a problem that only has one piece of information needed. D equals 8 times T. What am I solving for? So we cannot do anything at this moment. So now let's go to the vertical sense. Okay? We have a VI of 0. We know our acceleration is -10. Our height is -15. Why? Because the object is falling down. And T, we are looking for. And remember, time, whatever we get for time, will actually go from both sides. That is the only thing that the horizontal and vertical part shares is time. So now we're going to use the information on the vertical side. My distance is -15. My VI is 0 times the T that we do not know, plus 1/2 of -10, which is our acceleration. Remember, we're only looking at the vertical side now. And the T, we do not have. So if we look at it, once we substituted our numbers, the only variable we have to solve for is time. Good. We always want to pick the side where we only have to solve for one variable. So we're going to solve for T. We already replaced our numbers in the formula. 0 times T cancels out. Anything times 0 is 0. Now we have -15 is equal to 1/2 times -10 times T squared. Well, since we're multiplying, we can multiply numbers together. What is half of -10? -5. And I bring down my T squared. We want T by itself. We're multiplying the -5 and the T squared. Opposite of multiplication is division. We have T squared, and this is equal to a +3. -15 divided by -5. We are not finished because our 3 is T squared, and we want just T. To get rid of the square, do the opposite operation, which is the square root. Take the square root of 3, and our T, our time is 1.73. And I'm going to just round to 2 decimal places. So if you go to your table, our question mark is gone for T, and I will write in 1.73. Now, if you remember on the horizontal side, we had a D equals VI times T. And we just needed one more variable with a number so we can do our calculations. Now, horizontal has the same exact symbols as the vertical or the same variables, so we're going to use the same equation. Now, on the horizontal side, and that includes the time, now we're going to put this information over here. D, we do not know. Our VI in the horizontal is 8, and remember that was the speed that the object was thrown at. Our time that we have is 1.73 plus 1/2. What is my acceleration in the horizontal? 0 times 1.73 squared. Now, anything times 0. In this section, the 1/2 times 0 times 1.73 squared. Anything times 0 is 0. Do not put this in your calculator because you're multiplying by 0. What you have left is distance is equal to 8, which is your VI, times the time that we just calculated, which is 1.73. Now we're just going to multiply. Distance is 13.84 meters. Now, if you, with all the work that we have to do, if you just forget what does this distance represent, take a look at your table. We already had the vertical distance, which was negative 15 because the object is falling down. And we got the 15 from the problem. Well, that means this D, this distance, is the range. This is saying that the object fell, that it landed, 13.84 meters from where it was thrown. The height was negative 15 meters, and it came out with a velocity of 8 meters per second. And you see the arrow is horizontally. Always have this table, have the numbers that's always there, and then have your blanks. Go through your problem and see what they give you, and then look at the questions to see what they're asking you and place a question mark in that space. And always remember when you're doing your calculations, vertical stays with vertical, horizontal stays with horizontal. They are separate, they're independent of one another, but your time, that number can go for both sides.